Okay, friends, this is section 1.2. We're talking about, can you define a good definition? And can you identify 3 undefined terms? There's a typo in definitions. Sorry, friends. I'll fix it before you get your notes. A good definition is, you have 5 things that a good definition is. A good definition is accurate, meaning it clearly communicates the concept. A good definition is understandable, which means it uses words that you already know and you clearly understand. A good definition is reversible, which means that the definition, if I give you the definition Jeopardy style, you could tell me the word. A good definition is concise, it's not overly wordy, and it is objective, meaning it avoids emotions, figures of speech, and time/space limitations. Okay, so we're going to look at example 1, and we're going to evaluate this definition. We're going to evaluate space, the definition of space. And it says the definition of space is the set of all points. So we're going to go through each one and evaluate it. Is this accurate? The object that is named is defined. Okay, space, the set of all points. The definition is not ambiguous, meaning we understand what that means. Space is the set of all points. It is defined. 2, is it understandable? Okay. While we understand set already, because so far we have learned that in 1.1, we do not yet know what a point is in geometry. So it may not be understandable. Is it reversible? 3. The definition is reversible. If we said, what is the set of all points? We could say space. Is it concise? Yes, we are using only the necessary words we need to use for this definition. And is it objective? Yes, there is no emotion set in this definition at all. So other than the point that other than the fact that we might not understand what a point is yet, this is a good definition for space. All right, so being that we don't understand the word point yet, let's look at that. Let's look at the set. We have 3 terms in geometry that we just accept. We accept and we use the definition as fact, okay? So these 3 are point, line, and plane. These are the 3 accepted undefined terms. They are the building blocks for geometry. So the first one is point. A point is a dot or location with no length, width, thickness. It is a location in space. Your illustration is important here. Even though we put a physical dot, a point has no physical dimensions. So understand, even though we have to put a dot there to show where that point is, it's no dimensions at all. This is the illustration. This is how we read it. That is point P. A line. A line is a set of points with extending infinitely in both directions. Okay? It goes indefinitely to the right and indefinitely to the left. The line also has no width or thickness. This is the illustration of line M. Now we could call this line M, or we could call it line CD, or we could call it line DC. Note the multiple notations. You could use the physical line word, line CD, or you can draw the little line arrow over the top. You could use the word line DC, or you could put DC with the little double arrow over the top, or you can write line M. That M is the little italicized M up above the line. The third accepted undefined term is a plane. A plane is a flat surface made up of points extending infinitely in 2 dimensions with no thickness. A plane is like a piece of paper that continues to extend both horizontally and vertically. This right here is our plane right here. Typically we use a parallelogram type shape to define a plane. And when we write the notation, we use the little italicized letter in the corner saying plane K, or we can use 3 points to name the plane with the word plane FGH. You have to use 3 points. Now there is no little symbol like a double arrow to go over it. We just write the word plane. 3 other definitions that you need to be aware of are collinear points. Collinear points are points that lie on the same line. Non-collinear points, they do not lie on the same line. And concurrent lines. Concurrent lines are lines whose intersection is a single point. So let's look at example 2. Use the figure to name the following 3 collinear points. So we just need 3 points on the same line. So you can pick what you'd like. I'll pick T, V, and S. Those are 3 collinear points. I could have also done, nope, that's it. That's it on that one, unless I draw another line. B, 3 non-collinear points. This is pretty easy if we did this. How about R, T, and V? Or I could have said R, T, and W. Those would have worked as well. And then C, 3 concurrent lines, which means they intersect in a single point. Well, the only point I see of intersection there for 3 lines is the point T. So the 3 lines that intersect at point T is line RT, line TW, and line TS. Now understand, I could have named these differently. I could have said line TR, line WT, line ST, or line VT. But there are multiple ways to designate that. A couple more definitions that we need to have. Like I have said, you will be up to your ears in definitions for this first part of geometry. But you have to get really comfortable with these definitions. So please get really comfortable with all the definitions that we're talking about, so it just becomes a language to you and not something you have to think through. So coplanar points, just like collinear, but coplanar points are points that lie in the same plane. Non-coplanar points, again, do not lie in the same plane. A coplanar line is a line that lies in the same plane, okay? So 2 lines that lie in the same plane. Skew lines are lines that are not coplanar. So that means these 2 lines are within different planes. Parallel lines are lines that do not intersect, and parallel planes are planes that do not intersect. This right here is the notation for parallel lines, just so you're aware of that. Okay, so let's look at an example. Let's look at example 3. Right here. Use the cube to name the following. A, 4 coplanar points. Okay, so there's multiple answers to these. I'm going to choose the points D, C, K, and L. So D, C, K, and L. They all lie in that plane that's on the side of the rectangle right here. This is the plane right there. Okay. All right. B, B says 4 non-coplanar points. So I can pick 3 of those points that I already had and one that's different, but I'll try something else. I want you to always look at the figure. So I'm going to look at this plane right here. There's a plane right there. And I'm going to pick 3 of those points. So how about A, B, and D? A, B, and D. Now those are coplanar points, but I want non-coplanar. So I'm going to pick one that's not on that plane, and that would be E. So that would work. C. C says 2 pair of coplanar lines. 2 pairs of coplanar lines. That means lines that are in the same plane. Okay? So if there are 3 points in the plane, you could use those 3 points. So for example, line AB and line BC. Those would be coplanar lines. Okay? Or if you wanted to look at another plane, plane or line EF and line GH, those would be coplanar lines. D says 2 pairs of parallel lines. Remember, these are 2 lines that will never intersect. They will go on and on and on. There are multiple pairs here we could pick. I'll say line AD and EH. Those are parallel lines. You have a bunch that could have happened. BC and AD, FG and BC. E, 2 pairs of skew lines. Remember the definition of skew. They are lines that are not coplanar, so they are on different planes. So let's look at this. What about line AE? It goes up and down, and line AB. Those are skew lines. Now there's a lot you could pick from, but those are the 2 I chose. You could also do EH and FB. And last but not least, a pair of parallel planes. Think about your cube as the top and the bottom. So I'll just say plane ABC is parallel to plane EFG. All right, so once again, there are multiple answers to this one. You just have to kind of look at the picture. So the work we're going to work on tomorrow is going to be 1 through 27 odd. Please make sure you're filling out your TRF as you have gone through these notes now. And remember to write a nice summary of what you've learned within this section.